Hi everyone, welcome back to making a Pokemon save editor in C. We have finally reached double digits. This is part 10. Um, just as I was about to sit down and start coding, first of all, I don't know why I look so blue. I have no idea what's going on. This is the first day I'm recording in which it's really cloudy outside and there's a window right behind my desk, so maybe that's what's going on, but I have no idea why I look so blue. We'll just have to deal with it. Um, yeah, so just as I was about to sit down and start coding, bearing in mind that I've just come out of like cleaning all over my apartment, mopping the floor, cleaning my desk. I sat down with this very nice cup of coffee and I spilt it all over my desk. So I've just had to clean that up, clean my desk once again, and now I'm sat down and ready to code. It's so funny how these things happen. As soon as it's clean, it just feels like no time at all until it gets dirty again. Anyway, so last time we surprisingly successfully were able to change our trainer name, which I thought was actually really cool because it kind of proves that the way in which we are encoding characters actually seems to work. The only kind of thing I want to look at here is what is actually our space character at 00. So I actually do think that unrecognized encoded characters should be 0 and just treated as white space. Because it does let you have spaces in your trainer name or your Pokemon name, for example, right? Let's actually find out, because I'd be curious to know. I'm actually going to mute the audio from this. What button was that? I don't know if you saw that icon, but so if we were to do that, like start a new game, I'm not going to save, but if we do our name, there is a space here, isn't there? Yeah. Yeah, there is. Okay. So I wonder if unrecognized characters, rather than be one of these control characters, should actually be 0x00. Now, I think this does actually have an implication for us, because if I was to type in my name again, let me do it with, I don't know, 2 H's. When it prints what's been encoded, there are some characters in our input string that get converted to zeros. So I actually wonder if we want to break out of this while loop when we encounter the null terminated string of the null terminator in our input string. But then there's no bounds checking. Or, I mean, there kind of is, but it's... I don't know, maybe it should be when whatever's encountered first, a string terminator or ILEN. Because I have a buffer of whatever it is, 7 characters that we read. Because that's our maximum. So I need a way of only encoding the characters that are in here but not anything else. And the thing is, I think if we create a string this way, the null terminator isn't there for us. I don't know. I should probably research this. Let's just type in some vague search things here. So let's see what Stack Overflow says. Yeah, okay. So my question is, if car A5 contains only 2 characters, say AB, then that, yes. But if the input is, say, A, B, C, D, E, will A5 contain the Terminator character? If yes, why? Size of A will always return 5 as the answer. If you type more than 4 characters, then the extra characters in the null terminator will be written outside the end of the array. Overwriting memory not belonging to an array. This is a buffer overflow. C doesn't prevent you from clobbering memory you don't own. Your program can do anything. So that's just what undefined behavior is. Okay. So we actually always need to have a buffer that is 1 larger than what we need to enter. Hence, there's a 7, I assume, hence there's a 7 character limit on people's names, because we always need some kind of termination character in the games. What happened there? Okay. And what's this? Always return, wait. Oh, okay. So both name and encoded need to be 8. Now, I wonder if we can actually... I don't know if scanf does this bounds checking for us. I assume it does not. And it just lets us assign wherever we want. So the scanf family scans input according to a format. They are stored through the pointer arguments. Okay. What the heck is a DU? A DU? I have never heard of that before. Okay, so I think this is just saying that. So, what is the way we can do bounds checking then? Okay, it is possible to limit the amount of characters read by scanf. Okay, so we actually want 7 there. So I guess we can put in as many characters as we want for the name. Scanf is only ever going to read 7. Yeah. Alright, I think that should work. Let's do like a crazy long name and see what it did. So it went to Frederi and converted... Oh, wait, no, that is character number 8. But it's still converting it and trying to add it back. So I don't know if our game's gonna like that. That's not actually where I want to be. I want to be in GBA. So what I think has happened is in the last slot of our trainer name, instead of an FF like we've seen in previous episodes in the file, it's actually returned a 00, which might or not be a corrupt save. But no. It has actually done that bounce check for us. Oh, but it does not like our name. F-R-E-D-R-I. F-R-E-D... Oh, E-R-I is 7 characters. Oh dear. I don't know what happened there. I assume it tried reading the name from the save data and it didn't find the proper terminator, so it just kept going. I'm just guessing here, but if we were to go to our hex editor, probably somewhere like here, I can't zoom in too far. Where was our... So offset 11,000 is our name. So this is F-R-E-D-I. Now this is supposed to stop with an FF. So really this is not working. Now I wonder if we can just check for a string terminator anyway. Maybe we can say... let's say if a string terminator... before ILEN... I don't know, let's say before the encoder has encoded ILEN characters, the encoder stops and all remaining string is filled with FF. If a string terminator character is encountered before the encoder has encoded ILEN characters, the encoder stops and all remaining space in the output string is filled with FF. I think that sounds good, but what I should say is... in OS is filled with FF. So I think all we need to actually do is just check here. If... yeah, if this is our string terminator, then we just need to break, because we're already setting our output string to FF. So it's just going to kind of ignore the last character. And I actually think here in default we should printf unrecognized input character that it was replaced with 0. And that actually needs to be ISI. And we need a new line. So this loads our kind of trashed file. So let me put this back. And let's run this program again and use that same name. So I'm just going to use something crazy long, Fredrickson. So it does say it's encoded 7 characters and it's shown the index and value of each one. And so this is what our encoded characters look like. Now that looks correct to me. So this should now work and not crash when we try and look at our trainer card, which I can't remember if I did when I first changed our trainer name. And I need to change this to, oh my god, I'm going to use the terminal. We just want to do that again. Just finders, always so much more slow. Alright, so that is our name. Can we look at our... Oh, it might be because we didn't enter a new area, actually. Although it does load our name properly now. And it does show the correct... Okay, it does show the correct gender in the trainer card as well. And now we should turn into a girl. Yeah. Cool. Alright, that's pretty nice. So that is also working now. Let's... do some better, nicer printing here. Let's just call that encode. Do I want square? Ah, it doesn't matter, does it? So... I kind of want to clean up all of this code here. So this was stuff we wrote in like part 1, part 2. These functions like being able to actually read the data, and then just kind of erroring out if we can't. I mean, a lot of this is duplicated. This was where I was just reading initial values and checking that they were the same. So I think the time has come to prune all of this code that has been hanging around for far too long. I did also say last episode that I wanted to refactor a few things. I kind of wonder if it is worth going through some of these printfs and actually checking that they're still needed. So I don't think we need... any of these. Yeah. Yeah. This one is to actually print the section address, so that's fine. It might be worth actually writing some comments. And I don't know if these, like, where do docstrings normally go in C? Sure, and size C. You can use the Java doc standard. Okay, there's no standard way. Does Doxygen prescribe a way? Use a block of at least 2 C++ comment lines. They usually go above in a function body? What? Well, what about languages that don't have classes? Oh, here. I don't know if I like that. Oh, we can probably convert to that another time. We can just leave it like this for now. I'll keep them inside the function body. So, so this function returns a pointer to a game save section within a given save block based on input ID, or it will be within the given save block based on input ID. I mean, this function name I feel like is kind of descriptive enough, but we'll write one more for get the latest block once I blow my nose. So my hay fever's actually been fine the past few days, but now it's just completely flared up again. It's always when I sit down to code as well. You know, the air purifier's working overtime as well. Whatever. So based on input save file save, return, or just say this function returns a pointer to the latest or to the save block that was most recently saved by the player. It does this by checking the first section of each save block, or yeah, the save index value of the first section of each save block, returning to the largest save index value. Does this by checking the save index value of the first section of each save block, returning the corresponding save block to the largest save index value. Yeah. Cool. Okay, do we have other functions that we want to do? Yes, we do. I don't think we also need this start adder function as well, because we also have print section adder. So we don't need this code right here. It also might be worth actually enumerating the section names as well. So for each number, we actually print which section it represents. But that doesn't really add much, so I guess we can do that another time. What is going on? I feel like I need to sneeze again. Oh, it's no fun. My eyes are getting itchy as well. Which is strange, because I don't even have a window open or anything. Anyway, I'm gonna get rid of this code as well. So let's say this, or we'll say calculate a new for the input section S. For the input section pointed to by S. I guess it's calculate and return. Yeah. So there's loads of printing stuff here which we probably don't need anymore. But we can refine the logging messages a bit. Whoops. This is probably not needed anymore. And let's call these like intermediate upper and intermediate lower. So let's say original is that. And our calculated is that. So we need S checksum to go in here as well. Yeah. So what is our name? Our name is Josh. All these prints must be in here. Yeah. You entered the name Josh. Yeah. Where is it printing our address of section? It's whenever I call print section adder. Yeah. So our save data loaded correctly needs to have a new line after that. Yes, well done. But yeah, apart from that, that actually looks pretty good. So if we were to do this once again, it should have changed our name back to Josh. Let's find out. Yes, it has. Okay. Right, so I did have, and this was the reason why I went into this folder, I did actually have a roadmap of things that I kind of wanted to do. So I think it will be kind of fun to actually go through this list and see what we actually know that we have done. So calculating the checksum we definitely have done. We've changed the trainer name. Not only that, we've changed the gender. And we also determined the save block to be edited both by checking the save counter and by checking the... Well, I suppose we don't really check the ID yet, but we kind of know in advance which... Well, actually, yeah, just save block. So we do know the save block we want to change. So we're really working through our list of the initial goals. I think it would be really interesting to try adding a very basic Pokemon now. I'm pretty sure I picked Squirtle as my starter. So I'm curious to see what would happen if we tried to add a Bulbasaur to the team. Like I've put in the notes here, something very basic and low level with some very basic moves and stats. Just so we can kind of test a proof of concept, can we successfully add a Pokemon to our team? So I know, sorry, 1 second, that adding a Pokemon, it has its own structure. Pokemon data structure Gen 3. It is, they're all stored the same way in a 100 byte structure, and all numbers, as we know, are stored little endian. So this is like, whoa, all of the stuff. Oh, and interestingly, Pokemon have their own checksum. It is computed by adding all of the unencrypted values of that section, one word at a time. If the computed sum and the stored checksum do not match, the Pokemon is actually interpreted as a bad egg. Okay. Ooh. Now the data block is stored apparently in an encrypted format. And this has its own article about data substructures. Oh my goodness. I have not read this article before. This is a lot. Wow. The order of the structures is determined by the personality value of the Pokemon modulo 24, as shown below, where GAEM stand for the substructure's growth, attacks, EVs, and condition and miscellaneous, respectively. So what is condition? Is that status effect? Oh, it's a contest condition? Oh, like the... Oh, like a category of a contest. Okay. Oh, I see, but then doesn't this correspond actually to the Pokemon itself? Like, these things are inherent to... Well, actually, I suppose move and PP. Yeah, okay. Oh, and species is actually right. Okay. 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 So this is all of the data. All right. That makes sense. And then outside of that, outside of these literal what is it 48 bytes, there is all other stuff as well, like stats. Hang on, is stats not... Oh no, these are EVs. Okay. And these are the actual stats that the Pokemon has. Level, male ID, and then some unknown 2 bytes. Okay, right, okay. That is a lot. That is a lot. But let's create the structures for this then, I guess. So let's see. Is it Pokemon info? Yeah, let's just call it Pokemon. So we have, you know, I've written unsigned car so many times. It might even be worth just like defining a macro for it. Whatever. So this is personality, and actually, sorry, it's not even an unsigned car. It's a unsigned 32-bit word. And then this is the OT ID, the original trainer ID. Now this is an unsigned car. And that is... so it has a length of 10, but you can only... If it's a U8, then you can only have 8 bytes to a Pokemon's name. I mean, we'll leave it as 10 for now. So then we have... See, why does JetBrains do this? Like, spacing? Hello? See, why did it do 3 spaces? That's so annoying. So then we have language, which is a 8-bit integer. The code completion's just getting in the way here. Now, I wonder actually if that should be a structure in its own right. Miscellaneous flags. Has species. It is used as a sanity check for empty spaces. Oh, and any Pokemon without this flag set cannot be bred and will disappear when group selected. These are just padding for the other flags. They should be set to 0. Okay. Oh, but then these are bits, aren't they? I mean, what actually... How do we represent a bit? Consider using a car. Oh. You would have to bit shift them. I think... we should... use... Because the problem is we're going to need to make sure that we have this bit set. When adding new Pokemon. Yeah, let's do... has species, use egg name, no Ruby and Sapphire block. And that is 4 through 7. So we've got that. What is next? Now the OT name, which is a eight character string. Then we have markings, which is a uint 8. And then we have checksum, which is a 16. A bunch of question marks, okay. So it literally has, is there any description of it? Unknown, possibly simply padding, not used and usually set to either 0 or -1. -1? I thought everything was unsigned. Interesting. 1 second. So then what else do we have? Then we actually have the data. So let's create a type def for that as well. And we will call that Pokemon data. So then we have a Pokemon data, a status condition. Why did it change it to 32? Then a uint. I don't know what is going on with with Sea Lion. How weird is that? Mail ID. And then what else do we have? Luckily these are all 16, so I can just change these. So current HP, total HP. I'm going to call this attack stat, defense stat, speed stat, special attack stat, special defense stat. So if I've defined that correctly, we should see that data is 100 bytes when we define our Pokemon sub data, which is too large to actually show here. Now, this is interesting. It is dynamic depending on the personality value of the Pokemon modulo 24. So it's not a fixed structure. It can change. So I think we need to have implementations for every possible order of substructure. Which is really fantastic, and I'm very pleased about that. Yeah. How great is that? Now, the other problem we have is I don't know how to say... I guess we can just... We can make it an unsigned character array. But I don't really like that because it conflicts with what we have here. So I would be interested to see how to declare union types in C. Now, I guarantee unions probably don't exist in C. Although actually here it says they might. C union. We only declare the template of the union. We declare the members' names and data types along with the name of the union. Oh, it's a keyword? Really? Oh, it is. Okay. How interesting is that? Only one member can store data. Hang on, so is this just like a struct? Oh wait, this is not the same. This is not a type union. This is something else. Unlike structures, all the members in the C union are stored in the same memory location. Oh wait, no, we do want a union. Yeah. Yeah. Yeah, we want a union. This is not actually... I think what I'm going to have to do is... type def all of the combinations of... Let me actually... Of Pokemon substructure data. Or whatever the hell it was called. And then... add them to this union doohickey below. So yeah, this is not going to be a struct. This is going to be a union. And it's going to have a whole bunch of stuff in there. And we can't use a union in a struct. No. Okay. I guess it's a container. Ay. Okay. Ay. What are we gonna do? What are we gonna do? What are we gonna do? Unsigned character array for the time being. This should ideally use the custom structs. Structs we've declared. I'm pretty sure it was 100. Is it 100? My coffee's gone cold, but I finished it, so it's fine. It said something about... Oh, it's 48? Or it's 48. It's 48 bits? Or bytes? I thought it was 100. Oh, wait, no. Sorry, it's 100. All of this is 100. So this is 48, yeah. Of... Yeah. Okay. And maybe I should have been using, like, the actual type... What's this music? The actual types instead of unsigned character. But... meh. And it's not 100, it's 48. So... Oh, there's something else as well. There is an XOR encryption key. Pokemon's data is slightly more complicated than the rest. There are 4 distinct substructures, 12 bytes in length. Now, the order that we have depends on the Pokemon itself, and they are encrypted. Oh my gosh. The entire original trainer ID number must be XOR'd with the personality value of the entry. This key can then be used to decrypt the data by XORing it 32 bits or 4 bytes at a time. To validate the checksum given in the encapsulating blah blah blah, the entirety of the 4 unencrypted substructures must be summed into a 16-bit value. So the checksum that we had here is the output of our data section. And all of the unencrypted values of that section, one word at a time. Okay. Oh boy. Alright. Okay, I think we can do this. I say. I think we probably want to have a new file. Say .c file. And we'll call this I don't know, substructures. Or substructs. .c. Does it have an associated header? Why the heck not? Alright. So how did it know my full name? Is it reading that from my JetBrains account? That was weird. So yeah, we need to have many implementations or permutations of this, and I'm trying to think of the best way of actually doing that. I mean, I do think we just need to have all of the actual sections and then our permutations. So the actual sections are things like this. So growth, which is a species. Do we actually need... Can we just have a header file for this? Because there's no functions we need. Maybe we just need the header file. I don't know. I just want to get this written out first. So we also want int types.h. I don't know. What's... If I... this is a question for AI. Give me 1 second, because I've not used AI on these videos before, so let me just check that I've not got something on there that shouldn't be shown, but it's fine. Can you actually see that? No, you can't. How can I make it so you guys can see? Let me move myself. There we go. I'm writing a program in C, and I have lots of custom data structures I want to define. Rather than cluttering my main.c file, I've decided to place them in another file. There's no actual behavior with these data structures. Purely just type defs. Do I only need a header file for this? Or should I... I'm just going to say, do I just need a header file for this purpose? You do not need a separate C file just for these type defs. Okay. Yeah, they should not contain the actual implementation. Preprocessor includes your head. Yeah, okay. Makes sense. Thank you. In that case, we can take this and put it in here. Oh wait, hang on. Where does my end if need to be? At the end, yeah. So thank you, AI. Right. We can also include int types here, yeah? Yeah? Yes? And therefore we don't actually need this anymore either. But my CMake list is fine. Cool. Right, so let's go back to this article where we were filling out our sections. So we have lots of... So that's held item. Oh wait, hang on. 8 bits and a byte. I'm just going to call this EXP. And then this is PP bonuses, sure. This is friendship. And then we have a 16, which is unused. So that's our growth. Then we have attacks. And these are 16, 16. And then we have a bunch of 8s, so PP for move 1, PP for move 2, PP for move 3, and PP for move 4. Alright, then we have EVs and conditions. And we start with HP EV, attack EV, defense EV, speed EV, special attack and special defense. Two, three, 4, 5, 6. Beauty, cuteness, smartness, toughness, and then feel. I would be interested to see what the heck feel is. Oh, it's Pokeblock full meter. Okay, sure. So yeah, those are EVs and conditions, or EV condition. So then final one, if I can copy paste stuff correctly. What? Why is that? What? So annoying. Okay. Last one is miscellaneous. Will I be able to... Oh, yeah, there we go. I'm just going to call it misc. Attacks, EVs, conditions, miscellaneous. Where's growth? There, okay. GAEM. Sure. So first one is Pokerus. Metware. Origin info. IV egg ability. Ribbons. Obedience. And the origins is 16. And both of these are 32. Yeah. Okay. All right. So the issue that we have now is there's about how many permutations? And I'm going to put myself back where I was. How many permutations do we have? Where's this? I think I need to... Oh, yeah. No, it's here. Okay. Oh, that's not fun, is it? I wonder if we can do... like a quick and dirty Python script for something like this. So when I say quick and dirty, I don't know if it's actually going to be that quick or that dirty either. So Let's see if we can get rid of the numbers. Damn, okay. Do I literally just have to declare it twice? Yeah, and it's saying supposedly... Are these tabs? Yeah. And then any... Oh, will it let us actually insert line breaks? Alright, well that was not intended. Maybe let's just do space separated for now. Yeah. I don't actually know how I do that in Vim. Vim replace space with new line. Control V return. So let me put that on a new line. That... Oh, okay. That did work. Alright. Well, I'm not going to complain. Sure. So these are our structures. And I guess we just need to say... 4 structs in... Or 4 S in structs. Split it by new line. We need some kind of mapping of things like G. So if we get the character G, I want something that's like growth G. A would be whatever the heck we called it in Sea Lion. So attacks. And then E is E. Then M is misc. Okay, so for every line in our big thing there, we want to have our outstring. I'm just going to save it to a text file. Open. Just open a file in write mode. So our output string is something like type def struct that. I guess. So then we need to go over every character in S, and we well, actually, yeah, we can do that. So our inner string becomes the mapped character. And actually, I think we need a tab character in here as well. Object of type dict string string is not callable. I know it's... Oh, sorry. Brain. So actually, I don't think these parentheses are needed. No. So then we need to take outster. Is outster formatted with inner string first, and then S itself, because these are our combinations. Also, probably what I want to do is sort this string, or sort this list. So then that can become L. Let's see if this works. So, and that needs to be Python 3. Okay, it may have worked. Oh, whoops, I just opened the wrong file. Oh, I didn't write it. Durr. Okay. Should we do 2 line breaks? Why not? Oh my god, what did I call it? Substructure generator. Almost. That is not bad. Where the heck did the... Alright, so first of all, we're missing a semicolon there. Ah, okay, it's because of this tabbed character there. Probably what will make this clearer is if we do that. Yeah. And let's actually just call this a C file so that we actually get syntax highlighting when we try and read. My question is, though, where did the comma come from? That shouldn't be needed either. So in substructs.c, we are almost there. We still have some kind of tab indent, which we don't need. Oh, I guess that makes sense because we're tabbing in every time, so we actually just need a %s there. Oh shit. Did I actually save my latest changes? I did, okay. Yeah, I think this is fine now, so let's look at our output file. Yeah. There we go, those are all defined. That last line break, though, should not be there. Crap. Okay. The way we can check is every letter is unique, so let's get rid of the \ns there. If not s ends with c, then in a string should also have a not a semicolon, a new line. You're right, that needs to be in the for loop. Oh, actually, I need to close that. Just for avoidance of doubt. Lovely. Although, I don't know if I want tabs looking at that. I think I just want 4 spaces. We're almost there. We're almost there. Yeah, that's much nicer. Alright, cool. Cool. So let's close those. Let's go back here. So these are our substructures. So if I was to put them in here, and then these are our substructure permutations. So let me grab all of these guys and place them in here. Yeah. Let me just have another. Blank line there. Okay, so yeah, we're going to need a way of kind of dynamically being able to tell which we are going to need a C file, aren't we? Because all of that code probably should go in that C file. Yeah, okay. So Because there needs to be code that's like... Oh wait, how do we even know... Oh yeah, it's to do with personality and stuff. Okay. I mean, we could implement it in our main for now and then move it afterwards. I am just putting off the refactoring episode. Right, the issue that we have is what is our personality value? Is an unsigned 32-bit integer. It can be anywhere from 0 to that very big number. This value was introduced, yeah. Oh, they have an additional random unsigned. Yikes. Okay. Well, it's a good job we're doing Gen 3. So a gender is determined by the lowest 8. Ah, yeah. See, I was wondering actually where gender came into all of this. That is interesting. So the lowest 8 digits of P in binary form. Yeah, but how is that actually determined? Is it like if it's 0, it's female? Oh. If the gender threshold is not a special value... Wait a minute. In a Pokemon species data structure, there is a value called the gender threshold. Oh, it's inside of species. Okay, now we're really getting into the nitty-gritty, aren't we? So, in the... is it part of the data? Really, I should call this Pokemon data, but rather than substructures. Yeah, let's actually rename this file just Pokemon data. .h. And actually, these aren't even well, they are kind of substructure permutations, but we can just call them permutations for what they are. So where am I even looking? Where is this character encode? Okay, that's encoding. Let me close that tab actually, because we're kind of done with that for the time being. I wonder if I've missed something here. So from Gen 3 to Gen 5, a gender is determined by the lowest 8 digits of this number. That makes sense. Mathematically, this can be derived by calculating whatever that is, mod 256. But then there's a value inside here, which should be inside of species. Okay. Which is a gender threshold. So if we were to look at that and then look at... Oh, wait. This is something... Oh, okay. Wow, we really have levels deep articles, don't we? So, this value determines the chance that a Pokemon will be male or female. If the species is not any of those, then this value is compared to the lowest byte of a Pokemon's personality value to determine its gender. I see. Okay. I guess the game itself, or like rather than the save, knows whether a species is male, female, or gender unknown. I suppose. Okay. Sure. I can't believe we have, like, even more of these to kind of scope out. Oh, gosh. I don't even know where to start with these, actually. I think I'm probably going to stop for a bit. And we'll come back to this another time. And I'm going to have to read these articles a bit more thoroughly. And I'm going to try and come up with some kind of plan for what we can actually do about this, because this is fairly complex stuff. So, well, I say fairly. What I think will trip us out the most is probably all of these different kinds of, like, orders for the data. So I'm going to have a think, because this is, where am I looking in my markdown file? This objective of adding any extra Pokemon into the team is not as simple as I thought it was going to be. So, let's think cleverly how to do this another time. Anyway, yeah, I'll stop there. Thanks for watching, and I will see you in the next episode. Bye-bye.